Hi everyone. In previous videos when we were calculating the price elasticity of demand, we used this pretty straightforward formula. The percentage change, and that triangle there is actually the Greek symbol delta. The percentage change in the quantity demanded in response to a percentage change in price. So for example, if we knew that for some good there was a 20% increase in the quantity demanded, and that happened in response to a 10% decrease in price, our price elasticity of demand is 20% over negative 10%. Remember that price fell. And we end up with a price elasticity of demand of -2, meaning that for every 1% decrease in price, or 1% increase in price, so let's go ahead and write that out. For every 1% increase in price, the quantity demanded of this good will decrease by 2%. Okay? That's pretty straightforward. But what if you don't know what the percentage changes are? What if you've just got 2 points on a demand curve? So let's say when the price of a good is $10, you know that people will buy 5 units. And when the price of the good is $9, you know that people will buy 7 units. Well, unless you're really good at math, you can do those percentage changes in your head, you're going to need to come up with some method of calculating a percentage change. Now, one of the more common ways to do this is using a method called the midpoint method. And one of the reasons why this is a popular method is when we use this method, it doesn't matter which one's our starting point. It doesn't matter if we start at a price of $9 or a price of $10. Other methods, it actually does matter which price is your initial price. This one, it doesn't matter. But notice that word midpoint. It actually is telling us something. We are technically speaking not calculating the price elasticity of demand at either of these prices. When we do use this method, we are calculating the price elasticity of demand at the price that is midway between those two prices. So technically, we will be calculating the price elasticity of demand at a price of $9.50. So let's go ahead and do that. Let's start by keeping track of our price quantity pairs. So when the price was $10, the quantity demanded was 5 units. And when the price was $9, the quantity demanded was 7 units. So let's keep track of those prices and quantities up here. And let's introduce this midpoint formula. So the midpoint formula, or the way we use the midpoint method for calculating a price elasticity of demand, is I'm going to give it to you first in words, and then we'll do the math. So in words, difference in quantity over average quantity, all that divided by difference in price over average price. Okay? So difference over average over difference over average. So let's just plug in the numbers and do that. So the difference is 5 minus 7, that's our difference in quantity. And then the average quantity is just 5 plus 7 divided by 2. The difference in price, now this is where we do need to be a little bit careful. We need to make sure we use the right price quantity pairs in the right order. So we need to start with the price associated with the quantity of 5. So 10 minus 9, so that's our difference over average. Okay, now pause, take a minute to try to calculate this for yourself on your own, because it's good to get practice, and then check your work by watching the rest of the video. So 5 minus 7 is minus 2. 5 plus 7 is 12 over 2. 10 minus 9 is 1. 10 plus 9 is 18. Oh, sorry. Oh, 19. 10 plus 9 is 19 over 2. So minus 2 divided by 6 over 1 over 19 minus 19 divided by 2 is 9.5. Oh, there's that 9.5 again, right? We knew it would show up eventually. Now, I like to point that out because it's a good reminder when we see that we're not calculating this elasticity at either of these prices, but really we're calculating the price elasticity of demand at 9.5. So 2 divided by 6 is 0.333, and 1 divided by 9.5 is 0.105, roughly. So 0.33 divided by 0.105 is 3.17. So the price elasticity of demand between these 2 points was 3.17. So at a price of $9.50, for every 1% increase in price, quantity demanded will, those are negative, decrease by 3.17%.